Okay, we'll now solve a numerical on the thermal stresses. You should just remember one equation, that is what is the expansion, thermal expansion due to thermal expansion, which is alpha into delta T into L. If you remember this equation, then you can know what is the restricted expansion, because you know how much is restricted. So this equation you have to remember. Then this value of restricted expansion can be used in the formula dl is equal to sigma L by E. Of course, this is actually basically PL by AE formula, where this P by A becomes sigma. So this value of this restricted expansion has to be put here. So please write down a problem. Find the thermal stresses, find the thermal stress in a steel rod, find the thermal stress in a steel rod of 20 meter length, 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 heated to 80 degrees centigrade, okay, heated to 80 degrees centigrade from a room temperature of 25 degrees centigrade. From a room temperature of, make it, okay, instead of 25, you make it 20. Heated to 80 degrees centigrade from a room temperature of 20 degrees centigrade. Find the free expansion of the rod. Find the free expansion of the rod. Find the free expansion of the rod. Also find the stress. Also find the stress if the rod is blocked from both the sides. If the rod is blocked from both the sides, and all the expansion is prevented, and all the expansion is prevented. Then please continue. That is the second part of the problem, B. Continue. If the expansion is allowed by 0.01 mm, if the expansion is allowed by 0.01 mm, because of the gap at the ends, what is the stress because of the gap at the ends? Okay, if the expansion is allowed by 0.1 mm because of the gap at the end, what is the stress built up? What is the stress built up? Okay guys, now first we will actually try to analyze the first part of the problem. The first part of the problem says, basically it is a 20 meter rod, and the temperature is increasing from 20 degrees centigrade to 80 degrees centigrade. 80 degrees centigrade. Okay, now what I have asked, free expansion. So how much does it expand when it actually goes from 20 degree to 80 degrees centigrade? So free expansion, that is due to thermal expansion, dLT. So dLT, so that is change in length due to increase in temperature, is given by what formula? Alpha into delta T into L. Of course, okay, in the numerical, since now, is it a steel rod or an aluminum rod? It is a steel rod, and you know, for steel, alpha S is given by 12 into 10 to the power of minus 6 per degree centigrade. So here we know alpha is 12 into 10 to the power of minus 6 per degree centigrade. So you can actually put meter per meter degree centigrade or millimeter per millimeter degree centigrade or something, any way you want. And what is this delta T? So much is increase in temperature? 60. So that is 80 minus 20, which is 60 degrees centigrade. So here I put it as 60 degrees centigrade multiplied by what is the length? Length is 20 meters. So length is 20 meters. Now we can find dLT, change in length due to temperature. So what is the answer, guys? Point 0.024 guys. One thing you can do. So okay, it is meters. Yes. It is meters, or it is how much? 24 mm. So if you want to convert, 1 meter is equal to 1000 millimeters. So multiply it by 1000, you get it in mm. So you're getting in meters. Point? The answer is 0.0144. So when this value changes, so please. So then it becomes how much? 14.4 mm. 14.4 mm. Guys, please change a small value in the problem. There, now what is the gap given? 0.09 mm. Instead of that, please make the gap as 5 mm. For a gap of 5 mm. For a gap of 5 mm. For a gap of 5 mm. That's the second part of the problem. Now the first part of the problem is, I think this problem has got three parts. One is finding free expansion, which is already found out. So free expansion is already found out. Then the second part of the problem is, what is the stress built up in the steel rod when both the sides of the rod are prevented from expansion. So that means here, if you block it, if you block the rod from expanding on both the sides, if you block the rod from expanding on both the sides, here it wants to expand from now what is the expansion basically here? It is 14.4 mm. In the first case, there is no gap. It is completely blocked. What is the length here? This is actually 20 meters length. After 20 meters, there is a wall on both the sides. It is not allowed to expand. So 14.4 mm is the restricted expansion. Is the restricted expansion. If you restrict the expansion, then there will be stress. Then this restricted expansion has to be, it has to be substituted to what? It has to be substituted to this sigma L by E. So this restricted expansion has to be equal to PL by AE, which you can write this as sigma. So restricted expansion is how much? 14.4 mm is equal to sigma into L by E. So how much is L? That's 20 meters. So how much is actually Young's modulus? 200. So 200 GPa. So 200 into 10 to the power of 3 GPa, no? So 200 GPa. So this is, so Pascal is 200 to 10 to the power of 9 Newton per meter square, I'll write. So it is 200 GPa. I'll keep it in meters itself because here it is in meters. Otherwise, if you want this to be in millimeters to avoid confusion, so 200 GPa, you can write it as how much? 200 into 10 to the power of 3 Newton per mm square. So then you have to convert this into 1000, it becomes mm. Okay, so what is the value of stress that you get here? What is the value of stress that you get here? Guys, in the previous case, everything would get cancelled out. Degree centigrade will get cancelled out. This meter will get cancelled out. 1 meter is remaining. So we got this unit. Don't simply put the units at the end of the answer. think what you have substituted. From there you get the units. Either a meter getting cancelled, degree centigrade getting cancelled, left with the meter, you got the meter answer. And here, you will see here, what and all is getting cancelled here. So unit, so here the unit for stress is Newton per mm square. Newton per mm square. Only then this will get cancelled. Okay, it will be left with mm and mm on both the sides. So therefore the stress that you are getting is Newton per mm square. Newton per mm square. Because you have substituted this in Newton per mm square. Here it should be Newton per mm square. Only then this will cancel out. On either side will have mm. Don't write some random units at the end. Guys, use your calculator. Now what is the answer that you got? Huh? How much? 0.1. The answer is 0.1. Huh? Guys, I am asking stress, sigma.
So what's particular?
Guys, everybody is giving different answers. That means there can be only one right answer. That means most of the others, so all the others are wrong except one. Who is giving the right answer? So you operate calculator in a different way? Huh? 1440. Guys, anybody is getting this answer? 1440. 144 only. Guys, now I should actually use the calculator myself and find out the answer. Anybody is getting? Yes, 144, huh? 144. Guys, I am recording this video. It looks odd. 144. Guys, 144 Newton per mm square. Guys, 144 Newton per mm square means steel is within the yield stress. So it will not fail. It will not fail. So when the ends are, when you got a restricted expansion, then the second part of the last part of the problem. So here you got 144, the last part of the problem. First part of the problem was this. First part of the problem was this. Second part of the problem was this. And the third part of the problem, I'll write here only, erasing this. So that's in the part 3. That's in the part 3. With the gap of how much? 5 mm. So that means you got a steel rod which is actually 20 meters. Here you got a gap. Here you got a gap. So how much is the gap? Gap is equal to 5 mm. Guys, so that means this rod is going to expand by how much? 14.4 mm. It is going to expand by 14.4 mm. Out of that 14.4 mm, initially this 5 mm is free expansion. Initially 5 mm is free expansion. The remaining is the restricted expansion. Can you tell me what is the restricted expansion now? So restricted expansion is restricted expansion is 14.4 mm, which is the free expansion, minus 5 mm, which is the gap. So this is 9.4 mm. No change. You just have to substitute this 9.4 mm in this place. Instead of 14.4, you have to substitute this 9.4. Then you get the value of sigma. So that means substitute this 9.4 here. 9.4 here. Sigma L by E. So L is 20,000 meters. So 20,000 millimeters divided by Young's modulus. Young's modulus is 200 into 10 to the power of 3 Newton per mm square. So then I get sigma here. What is the answer now? 94. Definitely the stress will be less. So that's in the first case. First case, free expansion, no walls, no stress. In the second expansion, there is a wall, no gap, all the free expansion was prevented. So restricted expansion was equal to free expansion. So we substituted this value and we got this stress value, sigma L by E. In this case, there is a gap here. There is a gap before the wall. So therefore, initially 5 mm, the material expands. Only then the remaining expansion is prevented. Out of 14.4, 5 mm is free expansion, which should not be counted. 14.4 minus 5 is 9.4. That is the restricted expansion. So restricted expansion has to be substituted to sigma L by E. Then you get sigma. So here, since all the expansion was prevented, the stress was larger. Here, only 9.4 mm of expansion is prevented, stress is less. Suppose if there is no wall at all, it would simply expand. Then what is the restricted expansion? 0, because it is not restricted at all. Then if you equate this to 0, then stress will become 0. So like this, you solve numericals on stress related to temperature.